All right, so lesson 2 and lesson 3 are really about the mechanics of breathing and how you would go about measuring how much someone is breathing in and breathing out. So you'll see the 3 things that we're going to discuss: the mechanics of breathing, so what actually makes you breathe, how we measure lung volumes, and then we'll do a lab about that. So this first thing isn't new. You would have already written this down yesterday, but I just want to remind you that what's happening with your lungs is part of external respiration. Specifically, this is the exchange between the alveoli in your lungs, which are getting air from the outside, and your blood. So this is how air or oxygen from the air that's outside of you is getting into your bloodstream. And then the next exchange is how does it get from your blood to your cells? And the next one is how do your cells do something with that? But this is where external respiration is happening. So when we're talking about the process of breathing, this is the type of respiration that we're focusing on. So you have on that sheet with all the diagrams 2 more pictures that you would want to take out so that we can label some of the things on them. So you have 2 pictures that look fairly similar. One of the pictures is showing you what it looks like when you inhale, and the other one is showing you what it looks like when you exhale. And there's not a lot visibly different. We're talking about the same structures. But the thing that you'll want to focus on or take note of is which way things are moving. So we'll start with inhalation. During inhalation, notice the direction of the arrows. The air is coming towards your lungs, so we would assume the person's head is up here. The rib cage is coming up and out, and this part is moving down. Now, just like on the pictures we saw yesterday, sometimes we don't actually draw your whole diaphragm because it would cover up the whole picture. So on this picture, where we're looking sort of at the side view of a person, the red part is their diaphragm. So this is sort of side view. And then when we're looking at the front view of the person, that is their diaphragm. And so if you look at the front view of the person, the arrows are coming down the trachea into the lungs, and the arrows on the diaphragm are going downwards. Now you'll notice I have 4 words there, and those are the 4 things that happen in order when you inhale. When we do the next picture, exhalation, I'll use the same 4 words to start off with, but we'll say what is changing about them. Step 1 of inhaling is that your muscles, and when I say muscles, I mean your diaphragm and your intercostal muscles. So yesterday we labeled where the diaphragm and the intercostal muscles were on the top pictures that were on this page. So your diaphragm, which is below your rib cage, and your intercostal muscles, which are the muscles between your ribs, they contract. Now, when these muscles contract, it makes the structures that they're attached to move. The diaphragm, like we saw in the picture, moves down. The intercostal muscles, which are the ones between your ribs, move your rib cage up and out. So when your muscles contract, when these muscles related to respiration contract, it moves things. So diaphragm goes down, intercostals move your rib cage up and out. The result of this, by moving your rib cage up and out and your diaphragm down, is that you've created more space. So the thoracic volume increases. Now, what's the thoracic volume? This is the space in your thoracic cavity. So your thoracic cavity is the space in your chest where your heart and your lungs are found. Now notice in step 1 where I said muscles, at no point did I ever say that your lungs were a muscle, because they are not. This is one of the organs that is not muscular. A lot of the organs we've talked about so far are muscular. Your lungs are not. They're not part of the muscles. Your lungs are basically a balloon. And I'll show you when we do our little lab tomorrow, a little demonstration of a lung so that you can see what it looks like. But your lungs are basically determined, their size and their shape is determined by the pressure that's in your thoracic cavity. So, because volume has increased, now there's more space, air pressure decreases. And we're talking about pressure inside that same cavity. If you have taken chem or you're in the midst of taking chem, you might have already learned that when pressure increases, volume decreases. When volume increases, pressure decreases. They have an inverse relationship. So, since I now have more space, the air that's in my thoracic cavity is not creating as much pressure because there's more room for it now. And so what happens? Where does air flow? Well, we're showing it up here, and we're showing it right here. Air flows into your lungs. Air always wants to go from a place where the pressure is high to a place where the pressure is low. You could sort of think about it as being analogous to diffusion. Things move from where there's lots of them to where there are less of them. This isn't exactly the same thing because it's about pressure, not about concentration, but it's the same idea. Air will want to move away from high pressure towards low pressure, and making more space inside your thoracic cavity gives it that ability. So those are the 4 things that happen during inhalation. You could see there's 4 of them. You could put them in order. It would make a good put it in order numeric response type question. Now that's what happens when you inhale. When you exhale, I'm going to use the same 4 words, but just change what is happening in each of them. So I'm giving you a directive about how you should study this. It's the same 4 things, and they're basically going to be the opposite. So if, when you're studying, you know really well what happens during inhalation, you know that exhalation will just be the opposite of that. So the other picture that you have, this is exhalation or expiration, whichever term you want to use. Notice which way the arrows are going. The arrows are showing you which way the muscles are moving, and they're showing you which way the air is going. So just like the last one, we have a side and a front view. During exhalation, I have those same 4 things. My muscles relax. So, breathing in is what takes the work, the muscle work. Breathing out is when the muscles stop contracting. Now, this is for normal breathing. If you are breathing really deeply and really intensely, sometimes exhalation requires muscle activation. So yesterday I showed you that some of your intercostal muscles, you don't use them all the time, but if you are breathing really deeply, sometimes you have to use your internal intercostal muscles to force the air out instead of just letting it out passively. So, the typical scenario when breathing is normal and there's no stress on you would be that when your muscles relax, that is when exhalation starts. after your muscles relax, which means they move up for the diaphragm, or in and down for the intercostal muscles. So if you look up here, these are your intercostal muscles helping your rib cage move back in and down. This is your diaphragm here, and it's moving back up because it moved down originally. What happens to your thoracic volume? It decreases, which means that pressure increases. Pressure and volume are always the opposite of each other. If pressure goes up, volume goes down. So because we've decreased volume, now we have an increase in pressure. So air will want to flow out. Air always flows from an area of high to an area of low pressure. So that means now air will exit your lungs. So the only part in this where actual work is happening is when your muscles contract. The rest of it is all just a cascade of events that are caused by your muscles contracting and then by your muscles relaxing. So the increase in thoracic volume is only happening because your muscles have relaxed. The change in air pressure only happens because of the change in volume, and air flowing out isn't typically because it's being pushed out, it's because we've adjusted the pressure difference. Does anyone want to ask questions about either of these two diagrams? So we have one more thing to go over. And on this next little thing, I'm going to make a little graph as part of this. And you should make this too. There are a number of reasons. One, I would expect you to be able to read a graph of this nature and figure numbers out from it. Two, you're going to do a lab about this, so you need to know how it works. And three, it would be on a test for sure. I love graphs. So, the kind of graph that we're going to make is called a spirograph. It's the graph you get from a spirometer. A spirometer is the tool that you can use to measure how much air is coming out of your lungs. And tomorrow in class, we're going to do a little activity where you will measure this. Now, a spirograph is something that you would get from a fairly advanced type of spirometer. We have tiny, not sophisticated, not digital ones. So our spirometers are not going to make you a printout of what your breathing looks like. You would have to make the spirograph yourself. The first thing that we'll measure in the lab tomorrow is something called your tidal volume. It is the amount of air that goes in and out in a normal breath. So when we say normal breath, we mean you're not trying to breathe in extra, you're not trying to breathe out extra. These are the breaths that you take subconsciously. You're not even thinking about them. This is just the rate at which your body is breathing. On a spirograph, what we'll have typically is a volume, usually in milliliters. It could also be in liters over on the side. And then we'll have time along the bottom. Now I'm going to try to put some values that are fairly realistic here, but keep in mind this would just be a really, really loose average. It really depends on the age of the person, the size of the person, the fitness of a person, the health of a person. There are a ton of factors that would change these values. I'm actually going to start by labeling the middle of it, not by going from the bottom to the top. Because usually what the spirograph is measuring isn't just how much you breathe in and out, but your total lung capacity in the long run. So very typically, I'm going to put something like 2,000 here, 2,500 up there. So I'm just putting a couple of lines right now because normally when we start measuring a spirograph, we would tell the person to breathe in and out normally. And these normal breaths would show up in the middle of the spirograph. Now the reason they would show up in the middle is because there's still more air that you could breathe out, and there's still more air that you could breathe in. Your normal breath is just your average amount. Now if you look here, how much is your tidal volume? It would be somewhere in the neighborhood of a few hundred milliliters. 500 is a typical amount that's shown in a lot of textbooks and literature for an average, normal health adult person. So that would be fairly typical. It could be higher or lower, but this is a pretty typical amount. Now, how did I figure that out? I subtracted those two numbers. I took 2,500 and I subtracted 2,000. That's how I got that value off of the graph. Now, the next amount is your inspiratory reserve volume. I'm going to highlight the word reserve. This means this is extra that you have. Your inspiratory reserve volume is extra air you could inhale after a normal breath. So, your inspiratory reserve volume starts where your tidal volume ends and would be represented by the amount of air maximum that you could take in if you took the deepest breath that you possibly could. Now, inspiratory reserve is the extra amount. If I wanted to talk about every bit of air you could inhale, I would take those two values together and I would call it my inspiratory capacity. So if I take my normal breath and the extra breath and put them together, that's all the air I can possibly breathe in. That's it. That's the maximum amount. So, how much is this usually? It's usually a fairly decent sized number. A good estimate would be something like having 5,000 up there. That would mean that the inspiratory reserve volume was 2,500 milliliters. And again, that's just a rough estimate. The idea is your inspiratory reserve volume is quite a bit bigger than your tidal volume. Now I'm just going to put one more section of regular breathing in between so that there's a distinction. And the next one we'll do is expiratory reserve. Your expiratory reserve volume, keyword reserve, is very similar to inspiratory reserve. It is the extra air you could exhale after a normal breath. So, I'm going to make my expiratory reserve. I want you to notice that I, on purpose, did not make it touch the bottom of the graph, and I quite purposefully made it smaller than the inspiratory reserve. Now, just like with inspiratory reserve, this is not all the air I can breathe out, this is just the extra air. So if I took this and added it to tidal volume, I would get my expiratory capacity. That's all the air that you could possibly breathe out. So a normal breath plus every bit of extra air. Now, I don't normally use inspiratory capacity and expiratory capacity. I like to separate them all so that I have distinct parts on the graph. But your textbook mentions those, so I want you to know that's what we're referring to when we talk about capacity. Now, what would a person's expiratory reserve volume represent? I'm going to put a line down here, say around 800. So a person's expiratory reserve volume, a good estimate would be something like 1,200 milliliters. So that's the difference between 800 and 2,000. Key thing to note, it's bigger than your tidal volume, but it's smaller than your inspiratory reserve. Now the next word isn't actually a new measurement. It's when you take everything that we already did and put it together. So if I measured from here all the way down to there, that's my vital capacity. It is all the air that can come in and out, possibly from your lungs. So it is your tidal volume plus the two reserves. So it's just adding those three things up. So in this particular example, we would say that the vital capacity is 4,200 milliliters. The space between 5,000 and 800 on the graph, or if I just add those numbers up. So 4,200 milliliters, so that everyone knows, that would be 4.2 liters. There are 1,000 milliliters in a liter. That would be a unit conversion that I might make use of. Milliliters to liters or vice versa. So the difference is 1,000. You would divide by 1,000 or move the decimal 3 spots. That's how you'd convert. So this means a pretty typical person can breathe in and out somewhere in the neighborhood of 4 liters of air if they took the biggest breath in possible and the biggest breath out possible. Now the last part, which I will label down here, is this space where there's not actually a line on the graph. It's this empty space. And this is called the reserve or the residual volume. This is the air left in your lungs so they don't collapse. You cannot exhale this air. If you did, your lungs would collapse on themselves, and you would probably need help reinflating them. Now, if you've ever heard of someone being injured in such a way that one of their lungs collapsed, what happened is that somehow that reserve or residual volume got out of their lungs. Usually it's because their lung got punctured, and so now air that you can't normally breathe out just leaves because there's a hole for it to get out from. But your residual volume, you cannot purposefully breathe out unless you have some sort of injury going on. Your total lung capacity, then, is everything. So your total lung capacity is when I take the residual or reserve volume and combine that with your vital capacity. So the residual volume, I'm saying 800 milliliters here. Again, it's a very rough estimate. That means total lung capacity, I would say that it is your vital capacity plus the residual volume. So 5,000 milliliters or 5 liters.